When concentrated runoff is carried through a stormwater conveyance system and discharged, it is necessary to provide a stable outlet. Outlet protection measures or devices are placed at pipe outlets to prevent scouring at the point of discharge and reduce the velocity and/or energy of stormwater flows. In addition, they provide energy dissipation to reduce erosion downstream of the discharge. Designs for outlet protection in grade stabilization structures can be complex and generally require detailed site investigations and the application of sound engineering principles. A professional who is knowledgeable of the principles of stormwater management and experienced in structural design should be consulted when using these structures. This video is the fourth in a series focusing on active construction site best management practices, or BMPs, for handling stormwater runoff, including erosion and sediment control. In this video, we will cover the practices that protect outlets and establish stabilized grades. Video topics include energy dissipator, chutes, pipe drop structure, and toe wall structure. Energy dissipator, outlet protection. What is the practice? What does it do? An energy dissipator, or outlet protection, is an erosion control measure consisting of a riprap placed at the outlet end of culverts, conduits, channels, and so on. There are many types of energy dissipators, with rock riprap being one of them. How does it work? Energy dissipators prevents erosion at the outlet of a channel or conduit by reducing the velocity of stormwater flow and dissipating its energy. How to install? Divert surface water runoff around the structure during construction so that the site can be properly dewatered for foundation preparation. Excavate, fill, compact, and install as shown in the construction plans. How to maintain? Replace stones, ensuring placement at finished grade. Repair damage to the underlying fabric, erosion, scouring, or undercutting immediately. Temporary devices must be completely removed as soon as the surrounding drainage area has been stabilized or at the completion of construction. How to inspect? Inspectors should check for stone displacement and/or damage to the underlying fabric, erosion or scouring around sides of the apron, and piping or undercutting. Chutes, including rock-lined, concrete block, and reinforced vegetated. What is the practice and what does it do? A chute is a stormwater conveyance measure consisting of a defined channel lined with riprap, standard concrete blocks, or a three-dimensional matrix that has been filled with soil material and stabilized, with vegetation that is used to convey water down a steep grade in a non-erosive manner. How does it work? Establishes a stable grade and prevents erosion and head cutting at the outlet of a conveyance channel. Also establishes an in-channel, stable grade transition and provides for flatter channel grade in the upper and lower reaches of the conveyance channel, thereby reducing flow velocity and reducing potential for in-channel erosion and head cutting at the point of transition. How to install? Divert surface water runoff around the structure during construction so that the site can be properly dewatered for foundation preparation, construction of head walls, apron drains, and other structures. Excavate, fill, compact, and install as shown in the construction plans. How to maintain? Make needed repairs immediately using appropriate size stone and ensuring placement at finished grade. Remove accumulated sediment. Do not drive equipment or vehicles on chute structures. How to inspect? Inspectors should check riprap-lined chutes for stone displacement, check all chutes for erosion along the sides of chutes, scouring upon aprons, and piping or undercutting. Hydraulic structures. What is the practice? What does it do? The hydraulic structures referred to in this section of the video are hard, armored solutions that use concrete and rock for erosion control protection. Various hydraulic structures such as pipe drop, toe wall, head wall, and wing wall can also act as erosion and sediment control devices by helping to control site drainage and stabilizing installed separate stormwater pipes in their inlets or outfalls. How does it work? Drop structures provide protection for high-velocity hydraulic conditions that allow a drop in channel grade over a relatively short distance. They provide controlled and stable locations for a hydraulic jump to occur, allowing for a more stable channel downstream. Pipe drop structure. What is the practice and what does it do? Drop structures provide a structural base and energy dissipation for a significant grade change. Steep slopes can cause an erosive velocity, so grade breaks must be armored to prevent erosion from occurring. How does it work? Pipe drop structures provide an alternative to the natural slope. How to install? Construct as shown in construction plans. These are engineering solutions and practices. How to maintain. Keep clear of obstructions and accumulated sediments and debris. How to inspect. Inspectors should check for the presence of erosion or other type of deficiency such as pipe joint separation or failure. If rock is used, and if it is still present in adequate amounts, or is the structure free of cracks or other issues? Toe wall structure. What is the practice? What does it do? When stormwater runoff flows at the outlet of a structure and drops downward, the water will start to swirl and try to scour what it encounters. The toe wall provides protection at the outlet of a structure, thereby reducing the likelihood of scour at the base of the structure. How does it work? Toe wall structures protect the foundation of the structure to prevent scouring, failure, and erosion. How to install. Construct as shown in construction plans. These are engineering solutions and practices. How to maintain. Conduct visual inspections on a regular basis. How to inspect. Inspectors should check for any scouring, erosion, or settling of the structure, which are indicators of the structure not performing correctly. Controlled concentrated runoff, reducing flow velocities, and providing stable outlets on your construction site is vital to prevent unintended erosion. Please refer to local and/or state regulations and technical standards that contain the detailed requirements for your project site. Thank you for doing your part to improve the water quality in our local, state, and national water bodies. Our next video will discuss BMPs needed for temporary inlet and curb protection.